The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to our webinar on what's new in MecSoft CAM products for 2025 version. We are actually redoing this webinar. We did it about a month ago, and there were so many things to cover that we ran out of time to do the actual demo. So we figured that this time we will actually run through the product demo, go through all the changes by actually looking at some parts and toolpaths and things of that nature. So welcome, and for those of you who were attending last month, welcome again, and hopefully we'll be able to cover all of those exciting changes that we've just released. Yeah, as usual, to make the webinar interactive, use your chat window for questions. I'll be in the background watching and listening, and hopefully I'll be able to answer your questions. If we need to stop the webinar for some reason, if something's not clear, just raise your hand, and then we'll go from there. And hopefully we want to restrict everything, all the questions, to what's shown in the webinar. Sometimes we do get questions that are unrelated to the webinar, and unfortunately we will not be able to answer those questions for obvious reasons. So if you can please restrict your questions to what the topics are being discussed, that'll be great. And then, as usual, the recording of this webinar will be made available in a couple of days to all the registrants, and this is an open webinar, so it'll be sent out to everybody, so you'll have access to it on YouTube. First of all, I don't know why there's a molds and castings title on that slide, but it's okay.
That's a typo.
What's new in 2025 is the webinar, in case you're wondering what that's about. Anyway, first of all, before we jump into the agenda, I want to say that we just released the product yesterday. If you're eligible for the 2025 version, you would have gotten an email. In some cases, you could have gotten multiple emails because your license was eligible to be run on different CAD systems. For instance, if you had Rhino 7 and then Rhino 8, and then you had licenses for both, then you would have gotten 2 emails. And if you had some old licenses, multiple emails, you would have gotten multiple emails saying that 2025 has been released. So basically, there's just one announcement to announce that both RhinoCAM 2025 and VisualCAD CAM 2025 have been released, and they are now available for downloads. Anyway, jumping into an agenda, we're going to be talking about all the 2.5 axis, 3-axis, and 5-axis enhancements in our product that went into the 2025 versions, as well as the hole making, of course. And also, we will talk about some of the simulation and usability enhancements, and some of the other things like post enhancements and SDK enhancements. We'll talk about it. Really nothing to show in the demo. So all of these topics in the agenda are really things that are tailored for what we can show in part files and toolpaths. So Don, I'll be joined today by Don LaCourse, our support manager, and he's actually going to be doing the demo. And so Don, go ahead.
Okay. Hello, everyone. Glad you can be with us today. And we're real excited about our 2025 version. And we got a lot to look at. So let's go ahead and just jump right in here. I'm going to show some 2.5 axis enhancements. So what we got here, and what I'm going to do is I'm going to actually run through the creating the toolpath so you can see how it's done, and we also have them in here in the setup already if you need to refer back to them. So what we have here is a prismatic 2.5 axis part. Prismatic meaning vertical walls, flat surfaces, nothing contoured, etc. So one of the enhancements in 2.5 axis machining is that we've added cutter compensation to a number of additional operation types, and I'm going to be showing you the hole pocketing and hole profiling. So let's go. Typically, you would, pocketing, hole pocketing. One thing I want to mention is that the hole profiling is a really excellent operation if you want to machine a very precise hole. And we've got a number of videos and case studies on that, so I just want to mention that. So first thing though, for hole pocketing, you would typically use that if you want to rough out a hole. You don't have to use hole pocketing, but we're showing you hole pocketing. So let's go in hole pocketing though. Typically you wouldn't use cutter compensation because it's a roughing operation, but if you plan to use hole pocketing as a finishing, because we actually have cleanup passes here in blue, which can enable the cutter compensation on the final cleanup pass. So let's go into, we're going to do hole pocketing first. Let's go into hole pocketing. And I've got this bottom edge of the of this circular depression selected. We're going to use a flat end mill. I'm not going to adjust any of the feeds and speeds. Clearance cut parameters. So we have a tolerance of 0.03, and now we have a new compensation option here, which works exactly the same way as our existing other operations that had cutter compensation. So we're going to turn it on, and typically, you can set these values to however you want. Nothing really major has changed other than the cutter compensation. So we're going to go location of cut geometry is at the bottom of the cut, and the cut depth. Let's look and see what the cut depth is. So the cut depth is 11 millimeters. This drawing is in millimeters, and for arcs, we're going to use the arc diameter because we're using an actual circle at the bottom. If you just used a point to do the hole pocketing, you could just uncheck this and select the point. And we're going to just leave it a climb offset distance. We'll leave that. Now for hole pocketing and profiling, the entry is a helical entry. The entire path actually is a helical pass except for the cleanup passes. In pocketing, you will helical out, to the outer perimeter. So we're going to leave these, the helix diameter and the helix height, we'll just leave those to the default diameters. No sorting. Toolpath optimization, I'll talk about that in another file here. So let's go ahead and generate that. So here is the hole pocketing, and looks like I don't have arc fitting enabled possibility. Let's look at this. Okay, so it's enable. Okay. So we have a helical, as you can see. Let's go ahead and do this here so we can see it. So we have a helical entry here. You can see it here, helicing down and cutting the cut levels. And looks like I probably didn't have the cleanup pass enabled. I'll leave that though. So let's go ahead and post this so you can see with the cutter comp. And I have, now one thing to note about cutter comp, it's not enabled automatically in your post. So if you're wanting to run cutter compensation and you're not getting the cutter comp codes in your G code, it's probably that it's not set up in your post. If you don't know how to do that, just contact us and we'll just send us your post and we'll set that up for you. But I have a Haas cut post that we have modified for CutCom. And let's go ahead and pick OK there. Let's post this hole pocketing. You can post that whenever you want. Okay, so here is our G code. So we got a G40 here to turn off compensation, and then a G41 turns it on, and it will be on all the way to the end. We should have another G40 here to turn it off. Okay, and let's go ahead and minimize that. Now also, I mentioned that we have cutter compensation for hole profiling, so let's go ahead and do that. Hole profiling. We're going to select the same circular curve at the bottom of the circular pocket. And let's go ahead and use the same tool. Entry and exit. We'll do a, now what's going to happen here is it's going to enter in and start doing the whole pocket around the bottom of the pocket. Okay. So we could do it to a long path where it would helical down, or we can do it to linear lines and arcs. We'll leave it on lines and arcs and see how it looks. Everything else looks good there. Okay. Look at the cut parameters again. Cutter compensation is on, and the location of cut geometry is at the bottom of the hole. And for the cut depth, go ahead and do that again here. 11 millimeters. Or you could use the determine using 3D model. And we got a helical pitch. This is actually your, you can consider, we're going to talk about thread milling. So it's a similar concept, the pitch between the actual helical motions. Okay. And we can tighten that up a little bit. See if we can get more helical motions in it. Leave that. Let's just generate that. Okay. So what you see here is we got one helical motion with a lines and arcs entry, and it helicals around to the bottom. It does a cleanup pass at the bottom, and then it exits out. If you don't want to have witness lines here, then you can go ahead and change this to a long path, and we can change this, a long path. That would be the entry. So then the only other exit option would be either lines and arcs or none. Okay, we just leave it to none. Let's generate that. So it does just a direct retract upward. And also want to mention,
a long path might. So Donna, a long path might not be a good option because it's actually the cutter changes direction.
I think you can control that by the cut direction. Let's see here. I don't
No,
think
no,
we
you
don't
can't
have a cut
because,
direction in whole profiling. Yeah.
a long path you cannot, especially if you're using mixed. Cut climb conventional, you cannot. So I would not use a long path unless you're cutting real soft material. So.
Okay, but if you didn't want to have it enter, in the direction, then you could just change the cut direction. I believe that would work. Let's see. Let's go back to see what that looks like.
But it won't work. It's the same issue.
Oh, it's still okay.
Yeah.
So it's best probably just to leave it at lines and arcs. Okay. If you guys got any questions, go ahead and put them in the questions bar. And Joe, interrupt me if you want to interject some comments. Also, we're going to be filling up the whole 1 hour with parts. So as we get along, I may speed up or slow down depending on the amount of time available. Okay, so let's look at thread milling. So we're going to use the same part, and we're going to look at thread milling. And we're going to mill, this is a 40 millimeter diameter hole here at the bottom that we want to thread. Let's go ahead and go into thread milling. Let's go ahead and select a thread here. Okay, so we got our thread profile selected. We're going to use a thread milling tool. It's a M40 by 1.5 pitch thread. If you want to look at that, see what that looks like. So we have now the thread mill can be a full threaded tool or can be a single point tool. And we got a thread pitch. This is the main parameter right here, the pitch of 1.5. And obviously we're using in thread milling, the tool is going to enter and then actually move into the thread and start cutting around it. So it's not like a tap tool. Okay, let's go ahead and get out of there. So let's look at cut parameters. We've added a number of new parameters. We can do compensation now and thread milling. And there's a couple of other new parameters in here. Let's see, we've got let's see, multiple cuts, a start depth. This is a new parameter here where you can actually start cutting at a distance from the top of the cut downward. If you want, like, if you have like a relief diameter at the top and then the threads start, you can tell it how far down where the start cutting at. And number of leads also, I believe, is a new parameter when you can have multiple interject if I'm describing this incorrectly, Joe, but you can have multiple starts where it can do one thread.
Yeah, Don, that we always had that number of leads. It's that the threads per millimeter and threads per inch is what's the new one that we have added.
Okay.
So,
okay.
And then number of starts is also new. So we could have number of starts, multiple starts for the thread. So yeah, multi threads on the same diameter. So
okay, let's generate this. Okay, so look at it only did it at the bottom. Let's go in and see what we got here. Let's remove those. Let's select the top. Take a look at the cut parameters. Okay. Start depth. Okay, thread length. Okay, that's what it was. I need to know what this distance is here. Let's move this up a second. Let's do a center point. Okay, so that's 19. Okay, so total thread length, I guess that would be 19. That's the diameter, major diameter. That should be, I believe, 40. Start depth, we'll leave that alone. Let's generate that. Okay, so here is the 40 millimeter thread milling operation. And the pitch obviously is the distance between each thread point. And again, the tool that we're using is a single point thread tool. But if you want to go ahead and post that, let's see, post that out. Okay, so up here we got the cutter compensation off, cutter compensation on, okay, and it stays on, should be staying on all the way to the end. The G40 here just turns it off. Okay, so we've had a number of new parameters, also cutter compensation for thread milling. Let's see, let's take a look at some 3-axis enhancements. This is a good one here. Let's go ahead and do this one. Where are you? There it is. So we've added toolpath optimization. If you were on the professional configuration, you may recall that we only had feed rate optimization in you could add it to your toolpath after the fact, okay, where you could, add the compensation, the feed rate optimization parameters to the toolpath after it was generated. Now we've actually added it to the toolpath operation dialog itself. So let's look at a facing operation. Let's go ahead and generate one. Facing. Select curve. Feed to speed, we'll leave all this the same. Repping 0.01, stock allowance, fine. We don't need to change really any of this. Cut levels, we're going to do one cut level at the bottom. Entry and exit, we'll just assume we can enter and exit with lines and arcs. Leave that to none. Okay, that's fine. It's got an additional tab here called Toolpath Optimization. Excuse me. this tab, you can use this tab on in 3-axis in the areas that are cutting flat areas, like if you're clearing flats, if you have clear flats on, or if you have a flat surface, these options will take effect. We have a flat area at the bottom of this, and actually I wanted to go in and add a couple of curves here.
Quick clarification on the toolpath optimization. When we say toolpath optimization, we're talking only about feed rate optimization. So that's all we're doing. We're taking the toolpath and optimizing feed rates in corners and things of that nature. So your toolpaths will be much smoother on the machine.
Mm-hmm. Yeah, you won't see that jerking motion as you go around corners. And here, these options are basically the same as they were on the toolpath editor. If you was in the Pro configuration, where you can set the actual feed rate reduction percentage. Okay, so let's look at what the feed rate is here. Okay, so let's just set this something we'll put it to 100 so we can see it real clearly what the reduction is. So we're going to reduce it to feed rate reduction percentage 0.25. So it's going to reduce it by down to 25% of your cut feed rate that you have specified in the feeds and speeds dialog. And then these other options here are what angle of the corner to look at, your included angle, anything up to 90 degrees. And then also some distances of where to start the reduction and where to stop the reduction after you enter and exit a corner. Let's just generate this. Okay, so here is our looks like I need to go at the bottom here. At bottom. I'm not sure why it's not going right down to the bottom. Okay, well, we can look at it like this. So we have a lot of
your cut depth was 0.
Oh, is that what it was? Yeah, I had it at the bottom of cut rate 0. It should put it right down here on this plane, but I'm not quite sure why it's not.
No, you have islands up there. That's at a higher location, so that's what it's doing.
Oh, I
see.
You
have a cut depth of 0, so it's not going below that.
Okay, so let's get rid of these ones. Let's get rid of that. Let's get rid of that, and let's go ahead and add them here at the bottom. We can use that one, and we'll use that one. There we go. Thank you, Joe. Okay, so we have a facing operation on this planar surface at the bottom. Let's go ahead and post this. Okay, so if you look at here, we have a feed rate here of 100. Okay, and then it reduces down to a feed rate of 25 at every corner. So it's basically that's going to speed up and slow down at each of those corners all the way through to the end of the toolpath. So here it goes back to 100. Here's 25. So this is a good option to use if you obviously if you have a toolpath that's got a lot of right angles, a lot of angles up to 90 degrees or whatever angle you want to add in there. It'll save a lot of wear and tear on your router, probably on your tools as well. Okay, so let's see what else we got here. Okay, so we did, here's another good one. I'm going to look at Faceting Controls. Let's look at this one here. Now, we've added, if you go to the options dialog and machining, we've added these parameters right here called meshing parameters, okay? And what this does is it helps in certain situations where you have the geometry is like a ruled surface and it's kind of twisted in on itself. Sometimes the calculations for the toolpath can get a little screwed up because of the definition of the way the surface is defined. And you will see this. Let's go ahead and show you that. If you look at these, let's regenerate those. Okay. So let's look at this one. So you see here, the toolpath has some irregular motions through that. And you will see that on the finished part, okay? And this only happened in certain types. You wouldn't have seen this all the time. You may not have seen it at all. But for certain types of surfaces, there was this condition, and we've added these parameters here. And
maybe I can explain a little bit deeper.
Okay.
So if you, excuse me. So one of the things in all of our surface machining toolpath methods, for instance, even in parallel finishing, we have this tolerance control, which is basically in tall, out tall. That defines the accuracy of the toolpath. And it turns out just that simple tolerance value is not sufficient to create a geometry, a mesh geometry that we use in machining, a starter machining, starter mesh that we use in the machining algorithms was not sufficient enough to create a good mesh for us. So we found that later after in very specific cases, like Don was mentioning, very specific rule types of surfaces, under especially when one of the rules railings on the rule was quite a bit different from the other one. That's when we see these issues. Yeah, like you're saying, you might not even have encountered this. Most people don't encounter this. So we in any case, so what we've decided to do in this release is actually give a little bit more control for the user to define the starting mesh for us. And that's what the mesh controls in machining and the machining parameters that Don was talking about. So these meshing parameters control the nature of the mesh that is being created. So if you see any issues like this in the toolpaths, like the wavy toolpaths that you've seen, you can control it by going in and changing the meshing parameters. And that should give you a much better toolpath. So go ahead, Don, show the toolpaths now.
Okay. Let's catch that. Okay, let's go ahead and regenerate these. So you see that it created a much smoother toolpath. So those wavy motions in the tool are now removed. Let's do this one as well. Now for this one, it's a little bit more difficult to see, but if you look in on it, you'll see some large transitions here. And if we roll up it, you'll see.
Hey, Don, before you regenerate, can you just copy, clone it, and then we can compare it that way? So.
Okay. While we're doing the cloning, I'll mention also we updated the clone and copy so that you can control the naming. A lot of people don't like that copy being added, so we've added controls for that. I'll show you that in a moment. Okay, so let's go ahead and regenerate this one, I guess. That one might take a little bit to go off the.
Yeah, that's one of the things that you need to watch out for. If you're setting a meshing parameter speed too tight, then you might run into geometry that's, too accurate, if you will.
Now it got rid of that effect. This area, what you're seeing here, is not.
Can you turn off the surface display?
I can go over to the simulate and turn it off. You see, you don't have. Let's see where that one is. That one. If you look in here, you see you got those artifacts in the toolpath. So in this one, they're gone. Should be a much smoother surface, actual surface cut. Okay, so let's move along. We'll pick this up a little bit. Also in 3-axis.
to talk about the copy before you did.
Oh
okay.
we can do that. We can go ahead and do the copy. Okay, so if you're doing a lot of cloning and copying, like if you copy this again, clone it again, it would just keep adding copy, 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 and it gets kind of cumbersome if you're doing it a lot. So we added this parameter here. Let's see, user interface. There it is. So we added this copy clone naming convention section here, where if you don't want to have the copy displayed, you can just turn it off, okay? Or if you wanted to add an incremental number, like it'll just add a 1, 2, 3, 4 as you go along, and I'll show you that. Let's just pick OK here. And let's get rid of that one. And let's get rid of that one. So let's clone this. You'll see that this is number 1, this is number 2. So the copy, if you don't even want anything, you can just go in and turn that off as well. You can turn this off as well if you don't want it. So now you can just clone it. It'll just be the same name as the one you're cloning. So that's what we're talking about there. So let's go over to some more 3-axis stuff here. Let's see here. Okay. We've added the ability to use a combination of both excuse me, surfaces and curves when you're defining a control geometry or a containment area to machine in 3-axis operation. So let's go ahead and this, if you look at it right here, we have the surface and the curve defined. Let's just show you how to do that. Let's go to parallel finishing. And what we're going to do is we're going to go over here. We're going to select the surface. As you can see, the surface is not interrupted. Okay. And then we're going to go over to the containment tab and we're going to add some curves.
Yeah, in 2024, you could not mix and match these, but in 2025, we are able to do that. So that's what's Don showing right here.
Yeah, and the curve doesn't have to be on the surface. You can just go down here and let's remove this, remove all of those. And let's add, say, this rectangle here that's not on the actual surface. Okay, so it'll serve as a nest. If you consider it a nested control area, where you have a surface, then you have an area on top of the surface that you don't want to cut. So you can consider that in a void region. I guess you consider that in 3-axis. Okay, let's go back over to. Okay, let's go to this one here. Now we've also added an enhancement to the professional configuration for 3D offset. I guess it's 3D offset projection pocketing. Let's see here.
It's 3D projection.
3D projection. Okay. So what we're going to do is we're just going to add. We can just pick the surface. We're going to pick that surface. The tool. We'll just use a ball mill. Cut parameters. Excuse me. We have this option here called corner cleanup loops in the cut parameters tab. So we're going to do outside corner loops, okay? And let's see what else we got going on here. Okay, we'll just leave all this. We can do arc fitting, I guess. Okay, let's just generate that. Okay, so if you look down here on the toolpath, and I like my toolpaths so I can see them. Okay, so it just adds these corner loops in the areas to, it's sort of like a cleanup, sort of like a remachining area. It gets some additional area cleanup in those corners, okay? And then also it will serve as a method that forget what I was going to say, Joe, where you don't have any, where you're adding the corner loops, like in 2-axis, where it eliminates the jerking motions on the machine. That sort of serves that purpose as well.
Most importantly, what will happen, what it does is, if you don't have that in very steep angle situations, it's going to leave a stub there, stub of material, uncut. So this allows you to actually remove that little stub. And this is also, even in finishing, it might not be apparent, but it might actually show in the finish of the toolpath, the finish of the cut part. So doing this actually will increase your finish accuracy. So
right. Okay. So let's go over to, this is a good one that people have been asking for a while. So we've got horizontal roughing. I'm just going to use this operation because it'll probably take a while to do the roughing on this one. So what we've added this option here on the cut levels. So prior to 25, what would happen is if you wanted to clear these flat areas, it would go back after calculated the other areas, it would come in and put a cut level right on this flat area to clear it right down to the part. So there would be an extra cut level here, an extra one here at the bottom, everywhere you have a flat area. And some people don't like the fact that you're using the same tool possibly, and you're coming in and cutting right down on this surface. And users have been asking the ability to add the stock amount to the flat area. So if you check this box, let's go ahead and just look at it here. Let's look at it in the front view, say. So now with that button checked, it leaves the stock in the Z-axis flat areas as well. So you can come back in and clear that flat with another operation if you so desire. So it just backs us up by the actual stock value here as well as down here. Okay, let's go over to adaptive roughing here real quick. And
before we jump into this, a word about adaptive roughing. Do you want to talk about that, Don? This is an extra module, so.
Yeah, it's a you can, like, an add-on module that it's not going to show up by default in your 3-axis menu if you haven't explicitly purchased it. So once you get that add-on module, it'll show up here in the 3-axis operation menu. And adaptive roughing basically is a constant contact toolpath where, let's go ahead and show you that. Let's look at the cut levels here. So it's a bitangential toolpath where the tool is always in contact with the surface, the material that it's cutting, okay? And we've also added these helical entry motions, and also where it transfers up. So we got all of the motions except for the transfers have radial motions added to them, so you can run this at a much higher feed rate. So we have a radial entry, a radial here, the whole toolpath is a radial toolpath, and so you can clear this material out in a lot less time. Feel free to jump in there, Joe, if you want to describe it any further.
Yeah, I just want to say a little bit more about this method. It's a highly advanced algorithm that actually keeps track of the uncut stock while it's actually computing the toolpath. So it knows exactly, as it's creating the toolpath, what stock it's going to be cutting and what needs to be cut. And so that makes it highly optimized in terms of machining time. And also, if you had a facing region, the toolpath will be very different, and in the sense that it is, again, like you said, like Don was saying, it's constant contact with the material, and it always tries to take the constant depth of cut. So your toolpaths on the machine runs, real smoothly, and you can really run it at high speeds. So it's a truly high-speed material removal method, and it's a separate module because it's takes a lot of effort for us to develop this module. So it is a separate module that's separately priced, but you can add it to the standard, any configuration higher than standard and above, you can add it to that. So even for it's not included in the premium. So if you want it, it's an added module. So just wanted to make that.
Okay, so that's basically all I wanted to show you in 3-axis. Let's pop over to 5-axis for a moment. So what we've done in the 5-axis curve projection machining, let's go ahead and open this up. We've added this section down here for cut side. Prior to 2025, if you did a curve projection, the curve that you selected is the curve that you're projecting down onto the surface, okay? So what might happen in some areas, if the curve was up here, okay, and you wanted to project it down, you might get some irregular areas in the toolpath where it's riding on this sidewall. So if you, a lot of what this operation is used in a lot of, like if you consider like a stamped, like a car body hood, like if you stamped it and you want to trim out along the edge to get rid of that material. So you selected the edge all the way around and you wanted to use this to actually do a 5-axis trim area around there. So what you can do now is you can tell it which side that you want the curve to be projected on. And then also you have an offset. So you can tell it, I want to project this curve, but I also want to offset it on this side of the curve out a certain distance to clear some material or just to move the toolpath to a better area that you want it to be projected onto. So in this particular example, let's go up here. This curve right here was selected and then the offset outward. And also, correct me if I'm wrong, Joe, it appears to be offsetting by the tool radius and then adding an offset to that. I could be wrong there, but that's what it looks like it's doing. So when it's
no, that's not what it's doing. It's just on. It just uses the distance that you specified.
Okay, let's go back in here a second. Okay. Okay. And the reason I asked that I had a cutting side set to 0 is that's why I was asking. Okay. So now you can control the side to cut and the how far distance from the curve.
Oh yeah, right. It uses the tool radius to offset, and then you can add additional offsets to it.
That's what I thought.
Distance.
Okay.
Yeah.
So let's pop over to. Okay, let's go to hole making. So we've added rigid tapping to our hole making suite. If you go up here, and we're going to do a tap and these holes right here. So we're going to use a tap tool, a rigid tap tool. And basically, and correct me if I'm wrong, Joe, in the rigid tapping, the cutter and the spindle are more synchronized, right? Where those two in tandem create the cut feed in the depth of the tool.
Actually, yeah, the spindle RPM determines the tap depth. That's what rigid tapping is.
Okay. So we've got, let's see what else we got here for rigid tapping. You just select it here for rigid tapping. And basically the other parameters are basically, not new, but it's a new type of CAN sockets you can output. Let's go ahead and post that. Let's see. Empty post name. Okay, so I don't have the post selected. Give me just 1 second. Let's just use that. Okay, well, it outputs a G84. Now, the actual code can be different for certain machines. So if you want to enable this and you're not getting it output correctly, just let us know and we'll format your post to the correct. Just send us like an example, of way it should be, and we'll get your post set up. But it's outputting a G84 with the additional parameters for rigid tapping. Okay. Let's see. I wanted to go to this one here to make sure we cover this. Now in 2025, we've added the ability to display the translational limits. Okay, so let me just go through a possible scenario here where you've got it set up. Okay, you've got your stock set up. Okay, you got your it's laid out the way you want, and you're running it on the machine, and you get some x-axis warning or a y-axis warning. Okay, and you're wondering what the issue is. Well, now what you can do is go over here and turn on your machine axial limits. Okay, so whatever the parameters that you have set in here for the min-max parameters for your machine envelope, so to speak, we turn that on, you see that the part is actually extending past the machine limits, and that will flag errors on your machine. Obviously, it won't go that far. So this just gives you an idea of where your machine envelope is, just to make sure that your part is within that envelope, and you won't have to deal with any errors on the controller itself. Okay, so I've got a number of usability enhancements. We still got 15 minutes. I'm going to go through them if that's okay. So I'm just going to drag this over here so we can see this, Joe. Okay. So I've got two slides here that we had last month. I'm just looking at those two slides again to go over the usability enhancements because we got quite a number of them. So we talked about, I'm just going from 1, 2, 3 if you follow the numbers here. So number 1 here, you may have noticed that the triad for the machine coordinate system, or the work 0 triad, looks different now than the machine within the world coordinate system. Just to give you an alert so you know which one you're looking to. Sometimes it's a little difficult to tell, especially in RhinoCAM, which triad was the work 0 and which one was the world origin. So we've changed that. And number 2 over here, we already talked about no, we didn't talk about this. Now there's a tolerance that you can apply to your simulations. So typically before this, you could have standard, medium, and fine. Well, now you can also add an additional tolerance. Be aware though that if you adjust this tolerance to a low number, it will take longer to simulate, but you will get a more accurate simulation. Number 3 over here, we've talked about the cloning and copying. Prior to 2025, when you cloned a copy, it appended the word copy on the end of the tool operation name. Now you can turn that off, or you can put whatever it is that you want in there, and also add incremental numbers to that. So you can have copy, with this check, it'll be copy 1, copy 2, etc. Or you can just have it turned off. Number 4 down here, we've added some options for the ability to save your post to the file when you save it, or load the post from the file when you open it. This is a good option here. Number 5, we've now added the ability to reset your CAM preferences to the default factory preferences. So if you get to editing a number of different things and things aren't actually working out for you, and you don't remember actually what you went back to change, you can just do a reset to the defaults, and then you can start from the factory default settings. And here they are listed here. If you want to go back, when you come back and look at this video, you can look at this. So let's just go to this one here. For number 6, this is a good one here. What happens sometimes is users will upgrade their version of RhinoCAM or whatever, and their post will be missing, okay? Or the post, you know, when they open up a file in the new version, the post field might be empty, or it might be the default post, and you're wondering where your post is.
No. I mean, Don, I'm sorry. Yeah, let me interrupt you. That's not the reason we added that button. The button is, let's say you had a post that was customized for you in your previous version, and when you download the 2025 product, you're going to get a whole set of new posts that come with the product, and it will not include your customized post because that was customized specifically for you as a customer. So in order for you to get that customized post and implement it in 2025, you will have to copy that post from the older version that you had over to the 2025 post location folder. And so before it was a manual process, you know, a lot of people had problems with it and questions with it. How do I take my post? I have my customized post. I can't use it in the latest version. So we've added this button now where if you had anything that was customized in your previous release, could be you know, multiple versions behind. When you poke on this button, it'll come back with a little dialog that says, these are the posts we found that are different in the older versions. Do you want to copy them over? And if you say yes, it'll copy all of that over to the 2025 location, and from where you can continue using these you know, posts. So that's why it was implemented. Sorry to interrupt there, Tom.
No problem, no problem. So if we look at number 7, we've added the ability to control certain dialogues that show up, and there's a number of them here. If you don't want them to pop up all the time, you can just check these boxes here. Typically, before 25, we had a few of these, but we've added a whole list of them now that you can have better control of the pop-up dialogues. This is an interesting one here, number 8. We've added the ability to force the control geometry to be calculated in the order that it appears. There can be situations, and Joe, you can pop in here if you want to clarify. There could be situations where this order may not be explicitly adhered to. So now there's an option.
Yeah, let me explain what those situations are. So this is in profiling, not whole profiling, just profiling, you know, typical profiling operations. So the users might, you as a user might select a list of curves that you want to profile. Before, internally, what we would do is we would look at all those curves and do some pre-processing of the geometry. You would take those curves, merge all the endpoint ones, and you might have some probably modeling errors in some cases, or if you have brought in DXF files, they might have some self-intersecting curves, maybe curves that are intersecting at the endpoints, rather not quite endpoint matched. So we do a lot of that processing, cleanup of the geometry, pre-processing. And when we do that, the curves that you selected might change the order because we are actually appending, you know, maybe a curve that was selected 10th to the curve number 1, and they become one curve. In that case, then the order is completely messed up. So users sometimes complained, you know, this is not machining in the order that I selected. So we've added this control now that if you're sure that you don't want the algorithms to touch your geometry and machine them as you select them, then that's when you would click on this button, and then our system will not do any pre-processing on your geometry. I hope that makes sense.
Okay. A couple of more to talk about here. We've mentioned the option that we added to add stock to cut levels. And I believe does this work also in when you're clearing island tops in 2-axis, or is this only in 3-axis, Joe? It shows here in 2.5-axis roughing, so it applies also anywhere that you in 2 and 3-axis where you have a flat area that you want the tool to stay off of by the stock amount.
Yeah,
you'll see this.
it's both in.
Yeah.
Sorry, it's both in 2 and 3-axis.
Yeah. I was just looking at the dialog here. It's 2.5-axis roughing, so you can use this option to force the tool to stay off of the flat area, but by a certain amount, and that amount is equal to the stock allowance. That's something that users have been asking for some time as well. And then also down here, we see it here, Joe, answer my own question. This appears to be pocketing where you've got a clear island tops checked, but you don't want to clear it down to the actual surface. You want to leave the stock allowance to that. So this is this option we added in both, and this is both in 2-axis, I believe, also in horizontal roughing. Yeah, in 3-axis horizontal roughing as well. That looks to be, I believe, the end, Joe. Do you want to talk in? We did talk about the post-processing at the end. Do you want to mention anything about that?
Yeah, before that, there was a question about how do I change my custom post folder? Do you want to show how to change that in the post dialog?
Yeah. So here's the post dialog. So here's the button we mentioned about the modified post. And Joe, I wanted to clarify, this button will go multiple versions back or only one version back? And get your post.
I believe it'll go. I'm sorry. Yeah, I think it only does one version, but I'm not quite certain on that. So
I have tested it, so I do know it's only one. So that's why I was asking.
I see. Okay. All right.
So you wanted to change your post. You want to
click. Go ahead and click on the button because it's activated. So it looks like you do have some older versions.
Yep, we got a couple of posts here that we used last month in the webinar. Okay, so it found those, and you can pick copy. So let's make sure this is a Haas 2025 and a Haas SPM. Okay, let's just pick OK. Let's see if it's in the list. Hey, there it is.
There's a test, yeah.
It added it to your post list. So that's a good option right there, Joe. Yeah,
and then can you show how to set the post folder?
Yep. If you want to set the post folder, just pick this button here with 3 little dots on it, and you'll come up with a dialog that allows you to go in and change the actual folder where your posts are located. Let's just change it here.
And that could be anything. That could be anything you want. So
yeah, we can. Yeah, we can just do it if you want to. Just add it to your desktop.
All right. Okay. Yeah, we're almost out of time. Yeah, I wanted to say a few words about the post processor enhancements. Obviously, because we have changed, we've added some new methods like rigid tapping and things of that sort. Posts have been enhanced to handle those cycles. We've also added a bunch of variables to the post to allow the post to be a little bit more representative of what the users are trying to do. This is especially true in the Python posts. We've added quite a bit of functionality that opens up a lot of things that we can do now. We have asynchronous writing of data. So previously we would, as the toolpath is being processed sequentially, we would write the posted data. Now we are able to actually save it all in memory and then process what's in memory after the entire toolpath has been processed, and then write it out to a file, which allows us to do a lot of neat things in the post processor. So those are things we really can't show, but as we move forward with the release, we'll be able to write some pretty sophisticated post processors.
I believe, Joe, did we add some additional examples in the Python post folder. Users have asked
Yes.
for additional example sample.
Yeah, there's the documentation has been updated and additional samples have been, well, the SDK samples have been updated, not the Python posts. We don't have any
Okay.
programs for that. Yeah.
Okay. Okay.
There are a couple of questions that I wanted to answer. When is the product ready for download? I think I mentioned that before. The product is ready for download today, so you can go to our website. You should have received an email on where to get the product and download it. Check your email, check your spam folders if you haven't seen it, and you will see it. But I will, as a long-term software developer and software user, when a product is released, typically give it about a week before you actually download and implement it. Because there's really last-minute changes that are happening. Just a word of caution. But you don't want to be on the bleeding edge, like I say. You want to be on the leading edge, but not on the bleeding edge. Anyway, so it's okay. All right. So yeah, it's ready for download. So you can download it anytime today. Until for the next year or so. We might have some service pack releases coming up soon too as well. So, and then where do I see a list of these changes? Yeah, I actually posted the links in the chat window. So you should have links to the what's new documents in both RhinoCAM and VisualCAD CAM, which is basically the same changes that went into both products. And you can show that button here as well, Don, if you go to the Learn.
Yeah,
you just had it.
Yeah, hold on a second. I'll bring this back over. I'm going to get it out of the way. That takes you to the what's new.
Right, and that's where you see all the changes. So, okay, there are a few more questions. We'll try to get that answered by email. We're running out of time here, so thanks everybody for attending. And as we mentioned, we'll clean up this video and send it out to all the people who registered. And looking forward to seeing you all next month on our next webinar. Thank you.
Thank you, guys. Take care.
Bye-bye.
Bye.